Hi, everyone. So thanks for having us this morning. It sounds like Yuri's spending $100 million to find aliens, and we have one here. An alien of extraordinary ability. Most of you probably know a little bit about Vitalik. I'm not going to go through his whole bio. That's what Google's for. But just as a quick, interesting background or note, I discovered cryptocurrencies in 2013. And for me, they were a brain virus is kind of the best way to describe it. When you first understand the concept, it's sort of all you can think about. And in the 4 years subsequent, all I managed to do was invest a little bit here and there, write a little bit about it, and just try and understand it. In that period of time, in late 2013, Vitalik, very young at the time, 18, 19, how old were you?
When I created Ethereum?
Yes.
Yeah, 19.
19 years old, conceived of the project, tried to build it on top of Mastercoin, spun it out as his own thing, and created what is the most exciting project in the space since Satoshi Nakamoto, whoever that is, originally created Bitcoin. And as you all hopefully know, it's a platform for distributed applications in a trustless, secure, decentralized way. And we're going to talk a little bit more about what that means. We'll try and keep it very high level because I understand this is a general audience. But yeah, without further ado, here's Vitalik. And we're going to talk a little bit about Ethereum. So please give him a big welcome. Maybe we'll just start very high level. In your own words, how would you describe Ethereum to the average person, why it's important?
Yeah, so first of all, there's two kinds of average people. There's the average person who has already heard of Bitcoin, and there's the average person who hasn't, right? So, I mean, for the first category, it's a bit easier because if you understand what Bitcoin is, and you understand that it's a peer-to-peer digital currency, and you understand that if you want to have a digital currency that's decentralized, then you need some kind of database to store how much money everyone has, right? Like if I have 100, digital Bitcoin dollars or digital whatever, cash, and I send 100 to you, and I also send the same 100 to someone else, then those are two transactions, either one of which is illegal by itself, but both of which are illegal in combination because they'd be turning 100 units of cash into 200. And this is the classic double spending problem, and in order to solve it, you basically need to have some system that keeps track of, have these coins already been spent? How much money do I actually have at any given time? How much money do I have the right to spend at any given time? And you can very easily do this with a centralized server, but if you want to do this in a way that's decentralized, which is Bitcoin's original point in the spirit of things like BitTorrent, it's actually a very hard computer science problem to figure out how to do it. And Satoshi Nakamoto probably came up with the first solution that really is practical in this kind of open permissionless context, which is the Nakamoto blockchain. And that was where the idea of blockchain technology in general came from. Now, where Ethereum comes from is basically you take that idea, the idea that you can use what I call cryptoeconomics, so a combination of cryptographic algorithms, things like hashing and digital signatures, and the kinds of economic incentives that keep systems like Bitcoin going, and use them to create these kind of decentralized networks with memory, so these kind of decentralized database-like things for a whole bunch of other applications as well. Right, so around 2013, people started realizing really that these blockchains are usable for much more than peer-to-peer digital currency. And the first major thing aside from Bitcoin was probably Namecoin, which was trying to do a peer-to-peer decentralized DNS. But then people started thinking, can you do other kinds of digital assets? Can you do smart contracts? Can you do financial agreements? Can you do registries about identity? Can you do all these other things? And there were so many applications that building a blockchain for each one doesn't really work. And so the core idea behind Ethereum is, you can have a general purpose blockchain. We can have a blockchain where instead of the blockchain working like a Swiss Army knife, where you have 5 different tools for 5 different categories of applications, you have a blockchain that understands a general purpose programming language. So, kind of like your phone, in your phone you have Android or iOS. And inside of Android or inside of iOS, you can have apps. The apps are written in whatever programming language they're written in. Anyone can create an app. Anyone can download an app and run it. So that was the kind of general purpose flexibility I was trying to bring to the blockchain world.
Yeah, it's amazing, the concept of a Turing-complete blockchain in the computer science speak that can execute any arbitrary program given enough resources is pretty incredible. And it seems daunting because the idea of a blockchain is that everybody, one of the implementations of a blockchain is that everybody executes a copy of the code on themselves to verify that what is supposed to happen actually happens. So that begets a whole slew of problems like scaling and trust and so on. But just kind of easing into that, what kinds of applications do you think an Ethereum blockchain is suited well for? Like applications you both have people building today and ones in the future?
Yeah, so I think there's a few major categories. So I mean, anything to do with like the currency itself is obviously going to be a major category pretty much forever.
Because you want the security associated.
Yeah, exactly. I mean, like currency seems to be naturally the kind of application that's fairly well suited because like the general way that I categorize like applications that are good blockchain applications is to think of what a blockchain is, right? So the way I define a blockchain is it's a decentralized system that contains some kind of shared memory. And in Bitcoin's case, the shared memory is how many Bitcoins everyone has at some time, but it could be anything. So a good blockchain application is an application that, number one, needs decentralization, and number two, needs some concept of shared memory. And the case for decentralization in cryptocurrencies themselves, I think, is fairly clear, but you can actually even go beyond that, right? You can think about, if you have decentralized cryptocurrencies, then you can build many other things on top of them. And there was this interesting idea that Nick Szabo came up with about 25 years ago that was called a smart contract. And he made an analogy to vending machines, right? So what he said was that a vending machine is a device implemented in physical hardware that basically implements the conditions of some kind of an agreement. And the conditions of the agreement here are simple. You put $2 in, water comes out. You do not put $2 in, water does not come out. If you do not put $2 in, but water does come out, then that's bad. And the vending machine is basically an encoding of this set of rules, and that also comes with a mechanism that keeps it at least kind of secure. Secure enough for $2 water bottles. Now with digital assets, you can think about this kind of concept and push it much, much further, because in the digital world, in the world of cryptography, it's this world where even individuals are capable of basically having cryptographic defenses that are strong enough to even sometimes ward off state-level actors. And when you have that kind of security, the possibilities go up, right? So the general notion of a smart contract is that it's like a computer program that directly controls digital assets. Now, the kind of direct control here is important, right? It's not a computer program that makes a recommendation to a guy about how the guy should control the digital asset. It's a computer program that controls the digital asset. Like on Ethereum, you can literally send a bunch of Ether into a computer program, and once you've done this, the computer program itself has basically the unilateral ability to control where the money goes. If the computer program sends the money to address A, it goes to address A. If it wants to send it to address B, it goes to address B. And if it doesn't want to send it anywhere at all, then the money just stays there. And you can see this being used in a bunch of applications like insurance, just like any kind of self-executing financial contract. You can reduce counterparty risk in a lot of those kinds of applications by potentially a really huge amount. I mean, you could imagine it being used for more complex things. So there's this idea of DAOs, which are like these entire long-running entities that hold on to digital assets and basically use those digital assets in various ways according to these kind of fairly complex sets of rules. And you could even imagine, systems for crowdfunding. So if you think about what Kickstarter does, for example, it's people throw in money. If they've thrown in enough money within 30 days, then the money goes to the developer. And if they do not send in enough money, then everyone gets refunded. And that's like a set of rules that could be replicated in a piece of code. Now, outside the financial world, there's a lot of possibilities as well. So like the DNS is just one simple and natural one. And there is already a system on Ethereum called ENS, the Ethereum name system. And like this idea of giving human readable names that are in some ways like not tied to any kind of issuer is also one that just seems very interesting. You could imagine expanding this to identities. I mean, you could take this concept pretty far.
So you can replace money, you can replace Wall Street, you can replace core internet protocols. Right. What else can you do? In fact, I remember I looked at your About Me page, and it has this funny story. I don't know if it's real or not, but you first saw the power of decentralized, or at least the demand for decentralized applications when your World of Warcraft character had his rules changed on him by a Blizzard update. And that annoyed you so much that you had to go out and build something like Ethereum. So in theory, you could even build a massively multiplayer game on top of Ethereum, where everyone can have the rules verified, right?
Well, the story's true, though the fact that them nerfing Siphon Life and leading to me crying myself to sleep is what led directly to Ethereum is a bit exaggerated.
I do encourage you to check out Vitalik's About Me page. It's a riot. So now, obviously, if you're going to replace all of these different systems, you have a scaling issue. You have to figure out, especially with a centralized mechanism like that, even just to handle Visa's throughput, let alone every imaginable smart contract, that's not going to work if everyone's running a copy of every program on their computer.
Yeah, totally. So, if you look at just the raw numbers of blockchains today, Bitcoin is currently processing a bit less than 3 transactions a second, and if it goes close to 4, then it's already at peak capacity. Ethereum, right, over the last few days, it's been doing about 5 a second, and if it goes above 6, then it's also at peak capacity. So, on the other hand, Uber on average 12 rides a second, PayPal several hundred, Visa several thousand, major stock exchanges tens of thousands, and if you want to go up to IoT, then you're talking hundreds of thousands. And if you want to go up to non-financial applications, so like for example, there's a platform called Leroy, which is basically just Twitter on the blockchain, then you're talking also about hundreds of thousands, possibly millions. So, there is a kind of gap from here to there. And I think right now there already is really a lot of institutional hype in the space and just public hype. So when you have, like Vladimir Putin having, knowing what blockchains and Ethereum are, and Paris Hilton going out promoting ICOs on Twitter, that's peak hype. But the reason, I think a large part of the reason why a lot of this hasn't materialized into action yet is precisely because of some of these technical obstacles that make blockchains, work okay for some niche use cases, but not really work well for mainstream use. Now, our team is working very hard on various kinds of scalability solutions. So you hear about buzzwords like plasma, sharding, state channels, write-in, there's various newer ones like Perun. So if all of these are various different ideas that actually do try to kind of break through this fundamental barrier, right? That try to either create blockchains that still maintain a large amount of security without requiring everyone to literally process everything, right? So if you think about it, like one extreme is one guy processes everything, which is today's world. The other extreme is everyone processes everything. Well, what if you can get like square root of everyone, so like maybe 500 people processing each transaction? You still get enough decentralization and security for everything you need, but suddenly it's, within it's efficient enough that it actually works for stuff in the real world. And the other kinds of strategies are strategies that try to use the blockchain in a kind of more intelligently, right? So it's basically, like one of the analogies that like Joseph Poon from Plasma uses a lot is the idea of the blockchain as a court system, right? So blockchains are great at securely resolving disputes. And currently the way the naive blockchain applications work is they just put every single transaction on the blockchain. But what you could do instead is you could have systems where people send messages that I call kind of tickets, so digitally signed messages that are off-chain by default, but where the blockchain only gets used in those specific cases where there's a disagreement. So like if I have 100 digital, 100 ether, and I send you the 100 ether, then that might not ever go off chain. But if I send you the 100 ether and then you claim that I never sent you the money, or I claim that I never sent you the money, then that's a transaction that I could, we have a dispute, and I could actually push it down onto the blockchain, and so we still have a guarantee of security. Now, all of these approaches have their own trade-offs, and there's this huge amount of incremental technical work involved in figuring out what the right trade-offs are, but this starts looking like a direction that's much more promising.
And how far along are we? How long until you think that maybe we can scale to, as you said, hundreds of concurrent users? How many until we can replace Visa? How many until we can replace AWS?
I mean, for things like Visa, I think definitely, I would say a couple of years. So maybe 1 year when we start seeing like prototypes that have, like a low security level, but are still, secure enough for like major organizations to start just doing proof of concepts on. And a couple more years for all these solutions to really hit the mainstream. AWS is a trickier one because there are reasons why blockchains are, no matter how good they are, never going to completely replace centralized cloud computing. And probably even more, one of the big ones, there's probably two big ones in my opinion. One big one is that there are computations that are intensive and that are hard to parallelize. So decentralized clouds are really good at parallelization because it's like Uber for your laptop. You got millions of computers from millions of countries, millions of providers, all ranging from individual laptops to you can think of even cloud computing companies basically turning into like specialized mining farms inside of the system. But if you have computations that require like a really large amount of serial computation, then that's harder to decentralize. And the second really tough one is privacy, right? Like if you have computations on private data, then there's basically two approaches. One of them is to make sure the computations are only done on hardware that you trust. And the second one is to use fancy cryptography. So, you might have heard of buzzwords like homomorphic encryption and distinguishability obfuscation to do the computations. But then if you do that, then those tends to carry very serious computational efficiency trade-offs.
So basically for private or serial applications, you're going to do them locally?
Yeah, like in general, I think there's always going to be this large set of applications where decentralized approaches actually don't work that well, and that's fine. Yeah.
And so you're essentially building something between an operating system and a protocol for the world on the fly. It's going to take a decade probably to get to full scalability and hopefully adoption. What do you do in terms of there's a classic operating system developer question that they wonder about, which is how wide do I go and how high do I go? So do you start adopting other applications into the stack? All these people are doing ICOs, they're building layer 2 tokens on top of Ethereum. Do you see Ethereum adopting any of their functionalities, or does it stay as a broad, wide underlying layer?
One of Ethereum's slogans right from the start has actually been, we have no features, right? So a lot of the other projects are definitely going in that direction. They're saying, oh, we support this new class of transaction for issuing a token. Oh, we support this new class of transaction that issues an ICO, and look, you can have your 5 parameters with a cap, period, type of auction or whatever. But with Ethereum, we've never gone down that road, basically for a couple of reasons. One of them is that you want the protocol to be maximally simple because simplifying the protocol just improves consensus security. So the more consensus code you have in the protocol rules, the more likely it is you'll have issues like 2 different implementations not being in sync with each other, leading to the blockchain just randomly splitting in half. The other big reason, of course, is just unknown unknowns. We have really no idea what blockchains are going to be used for 5 or 10 years from now, right? And we don't really want. We are okay with making some specialized components that get used a lot. So Ethereum, we have a next update, Metropolis, which is coming in October, and one of the major things that's coming in that is explicit in-protocol support for certain kinds of cryptographic operations. So ring signatures, elliptic curve pairings, which get used as part of zero-knowledge proofs. So the major theme here basically being strong cryptography and privacy. And that is kind of specialized, but it's also very generic because almost any application could benefit from privacy. So we are willing to compromise somewhat in that direction, but we really don't want to compromise in favor of really supporting high efficiency in every single application. Now, if that means that there are specific application categories where some platforms outcompete Ethereum, then that's fine. We don't need to be everything to everyone. But there are also going to be ways to kind of specialize even within the Ethereum ecosystem as well, right? So there's projects like Cosmos, things like Plasma. All of these are trying to provide second layer systems that connects to Ethereum, and in many cases are even designed in order to take advantage of the base Ethereum blockchain for security, but that can have properties of their own, and that if they run well, could have things like a 500 millisecond block time, so you can run StarCraft on the blockchain. So, those things are possible, and if you adopt this approach where if you have Ethereum as this kind of base layer that, does a good job of balancing between the kinds of the high level of security and the scalability that a base layer needs, and then allows these other things with various different properties to get built on top, then you actually can have a blockchain ecosystem that works really well.
Got it. So you want it to be a secure base layer that doesn't have too many features and really lets the innovation happen on top. But you have things like privacy and security and consensus at the core layer. But the big application that everyone is obsessed about, in fact, I think the reason why people are so interested in cryptocurrencies these days is just because they're making money off of them.
Yeah.
So the fundamental application right now seems to be just money. And Bitcoin seems to be willing to, the protocol is in service of the currency. And here it seems almost the opposite. Is that fair to say?
The currency is in the service of the protocol. Yeah, definitely. I definitely say that is our philosophy. Although, I mean, yeah, like it's definitely the case that there's a lot of adoption purely because of like people's speculative interest. But then, on the other hand, like that's not, like that has a bad side and a good side, right? And I think one of the good sides really is that, in part because of this, there actually is a lot more interest in the possible social benefits of the decentralized technology than there are in like many of the other approaches that have been tried like over the last decade. Like if you look at diaspora, great idea, ended up failing completely, right? And like a lot of these kind of decentralized projects tends to not work very well, and in a large part because basically lack of funding and just lack of a kind of good incentive for actually building out the infrastructure. Whereas here in the cryptocurrency land, there's a lot of money, and at least that one particular problem can be solved.
Right. So now, because we've married the economics to the crypto, the incentive issues are solved, and economic incentives can unite people in a way that pure politics cannot.
Yeah, I mean, like crypto is really ultimately all about incentives on multiple levels, from the community all the way down to like the security of the consensus protocol. Like you just cannot reason about security of like blockchain consensus protocols without reasoning about economics. It's not about if like half of these people are honest, then we can prove the system is secure, or if Magic Bob in the sky is honest, we know the system is secure. The system is secure because we have mathematical proofs that say if the system breaks, then the guy who did it loses $100 million. Right, so that's what we mean by crypto economics, like combining together this kind of cryptography, mathematical proofs, and economic game theory reasoning all together.
So if you assemble all this together, it used to be in God we trust, then it used to be in nation states we trust. Now it's going to be in math we trust.
Yeah.
Are the nation states going to take this lying down? You just came back from China. You saw what's happening there.
Yeah, I mean, it's in the way that like traditional political, just economic powers are going to respond to all of this as like definitely going to be I think a big part of the story over the next few years. Like if you, it is ultimately it really does disrupt traditional power structures. And whether it's Washington, New York, or Silicon Valley, it really does pose serious challenges to the way that things are working now. But on the other hand, it's one of the things we've learned actually is that a lot of the people even inside these power structures seem not all of them, but at least some of them seem quite friendly to these ideas of disruption. Like there definitely are plenty of JP Morgan employees who are really excited about the possibilities of like blockchain technology, and like it's the fact that you work for a large company or that you work for a government, doesn't mean that you're a hopelessly boring suit, right? Like one of my favorite examples of this is that in Taiwan there's a politician named Audrey Tang, and she's transgender, and she describes herself as a conservative anarchist, and yet she is the head of, I believe, like the digital ministry of the Taiwanese government. Right, so like these kinds of people, this is obviously like someone who's particularly special, and she has been recognized as like one of the 10 kind of greatest programmers there. But to much lesser degrees, these kinds of people do exist, and large organizations in general are complex, right? You have people with one kind of belief on one side, with another kind of belief on the other side. Even if you look at the Chinese government, like their response, I think, has clearly been showed that there are different groups of people inside of the government who have like different ideas about which direction they want to go. And like lately, if you look at all the news about like them regulating VPNs and chat groups and so forth, it's obvious that kind of the arc of this decade is that the conservative side over there is winning. And to be fair, a lot of those things are happening in many other places in the world as well. But large organizations are definitely still diverse.
It's amazing China is finding out that its financial and capital control policy boils down to its firewall policy.
Yeah.
So we could talk for hours. I mean, Vitalik's knowledge is incredible. Here we've just scratched just the bare surface. Yeah. I encourage you to follow him on Twitter, where he's incredibly good-natured about all the trolls that are constantly attacking him. So don't be one of those people. Yeah. And learn everything you can about Ethereum, because it really is very much the future in cryptocurrency. So thank you for being with us, Vitalik, and after your short trip to China.